Today's activity is on the equations of hyperbolas. We looked at circles and ellipses and then changing forms, and now we're going to be looking at hyperbolas, another one of our conic sections. This conic section is actually made by two cones that are stacked kind of on top of each other, vertex on vertex. So we have actually seen hyperbolas before. That's what the first paragraph talks about. You can pause and read through that. But y equals 1 over x, that was a hyperbola that had opened not left or right or up or down. They opened diagonally. They are functions. The ones that we're going to deal with today are not functions. So we're going to take a look at those. The definition of a hyperbola is the set of all points in a plane such that the difference of the distances from two fixed points is constant. So it's kind of the opposite of an ellipse, where that sum is going to be equal. This is where the difference is going to be equal between those two fixed points. Some things to look at when we are looking at a hyperbola: the center. Notice the center here is not actually one of the points that's on the hyperbola. The vertex points, so I've got this over here at opposite A, over here at positive A. Those are the vertices, the foci. The transverse axis in this case is horizontal, meaning that the hyperbola is open left and right. We will have some where the transverse axis is vertical. So we'll look and see what makes that difference. Equation of the asymptotes: y equals b over a times x, and y equals opposite of b over a times x. It's looking at this line right here and this line right here. The y-intercept is 0, so that's why I don't have to have a plus 0 or a plus 0. And the slope, we're going to find out, is actually determined by this rise over run. So rise over run, I'm going up b and over a. So the actual picture, you're going up to b and you're going over to a. But if I just go this part of it, it's up b over a, and then the other one would be down. So that's why there's a positive and a negative. So we'll see that. So that's what we're going to look at. The next couple of pages there go through the development of the equation. So I'm not going to go through that. You will not be responsible for that. Just to know that it's not just made up. It again deals with the difference, or with the distance formula, and looking at the difference of those two distances being equal. So here you see I've got two of the distances being equal, and it's going to equal that 2a. So working through that, I'm not going to go through all that. I want to get into the actual graphing of it, because that's what you're going to be responsible for. So here's the equation. We'll get it down and simplified. You'll notice it is very similar to the equation for an ellipse. The only difference is, instead of adding, I'm going to be subtracting. All right, so that's our standard form. If it's vertical, then the y squared over b squared would be first, minus x squared over a squared. So that's how we determine if it's going to open left and right, or if it's going to open up and down, which is being subtracted from which. So we'll see that in some examples. All right, so when we're graphing, the process for graphing hyperbola begins the exact same way as the steps to graph an ellipse. Consider the equation, key information, and graphs for the ellipse and the corresponding hyperbola that's given. So here's the ellipse information from back in activity 2. So I've got a center at 2, -1. I've got a horizontal radius, that's going to be 8. I've got a vertical radius, that's going to be 4. So again, knowing what all of those numbers, what they tell us about the picture. Our key points, we go up and down 4 from our center. We'll go left and right 8 from our center, and that will give us those 4 points. And then we're going to draw the oval. So a few things to pay close attention to in the examples above. The equations are identical, except the ellipse has addition sign and the hyperbola has a subtraction sign. So you have to check that right away to determine, is it going to be an ellipse or is it going to be a hyperbola? Obviously, those look different. Both graphs and equations have the same center, horizontal radius, vertical radius, and key points. These are in quotes because, again, there isn't a radius with the hyperbola. We'll talk about how to graph that in a second. But here it is for the ellipse. Find the 4 key points and then draw that oval shape. So once we know the center and we know the horizontal radius and vertical radius. For the hyperbola, It has the same center, same horizontal radius, same vertical radius. Key points. On this one, the key points we actually still will graph, but what we're going to do here, instead of drawing over, we're going to draw a rectangle. So we draw the rectangle, the box around those 4 key points. By drawing that rectangle, what happens is I can draw extended diagonals through the rectangle, and those end up being the asymptotes for our hyperbola. So as this keeps going out, we're getting closer and closer to that line and that line in this positive direction and in the negative direction. So step 1, draw the box around the 4 key points. Step 2, draw in the diagonals of the box. Those are the asymptotes. So extend those out, and then draw the hyperbola shape starting at the key points on your transverse axis. So I know that I'm going to be starting here and here because it was an x squared minus y squared equals 1. So that is telling me that it's going to be the left and right facing. So this key point I picked over here, that's actually a part of my hyperbola, as is the one on the right side. These two, top and bottom, are really helping me draw my rectangle to help find those asymptotes. So opens left, opens right, and those are that's the steps to drawing the hyperbola. Next one, so ellipse, as we compare, again, find the 4 key points. So the center here is at 3, 0. Horizontal radius is the square root of 4, so we're at 2. Vertical radius is the square root of 49, so we're at 7. Key points, we'll go left and right 2 from the center. We'll go up and down 7 from the center, up 7, down 7, and then draw the oval shape. So there's the ellipse. Same idea for the hyperbola, but instead of drawing the ellipse with those points, we're going to draw the rectangle. We draw in the diagonals. Extend and extend. Same with the other one. And then this one was x minus 3 squared over 4 minus y squared over 49. So the x squared is minus the y squared, so I know it's going to open left and right. The 2 vertices of my left and right on the rectangle, those are going to be the actual vertices of my hyperbola. This one, you can see it goes up and down. It's kind of a wide one. Let me look at that. All right, so the next page on the activity is an example for you to actually try. So starting off with this one, a little bit easier, maybe even we have a center of 0, 0, horizontal radius of 2, vertical radius of 3. So that's where those numbers are coming from, just looking at the equation. Key points, I'm going to go left and right 2, negative 2, 0, 2, 0, up and down 3, 0, 3, 0, negative 3, and then draw the oval shape. Hyperbola, the only difference is now instead of drawing the oval, I'm going to draw the rectangle. I shouldn't say only difference, the main difference. And then I've got diagonals, and this is x squared over 4 minus y squared over 9. So the x squared is first, so my transverse axis is horizontal, so I know it's going to be opening left and right. So the 2 vertices we picked on the left and right of our rectangle, those are actually vertices of the hyperbola, and then head out and hug the asymptotes as we go. Next one, let's move it off of the 0, 0. So now I've got the centers at 1, 2. Horizontal radius is 4. Vertical radius is 8. So I'm going to go left and right 4. So negative 3, 2, positive 5, 2. Up 8, 1, 10. Down 8, 1, negative 6. Draw the oval. Hyperbola, now instead of drawing the oval, those same 4 points, I'm going to draw the rectangle. I'm going to draw the diagonals. X minus 1 quantity squared over 16 minus y minus 2 squared over 64 equals 1. So that tells me that's going to be left and right opening. So there it is. Notice the only difference in these two equations is that sign. This is a plus, this is a minus. So that's really the main thing you need to pay attention to know which of those two shapes you're going to have. All right, now let's consider the possibility that the hyperbola opens up and down instead of left and right. We refer to these two equations. So here I have a left and right one that we have just kind of looked at those. Now I have and up and down because it's a y plus 1 squared over 16 minus x minus 2 squared over 64 equals 1. So this one is now going to be one that opens up and down, but the steps are still the same. Find the center. The center is, the x coordinate is with the x, so it is a 2. The y coordinate of the center is with the y, so it is -1. The horizontal radius is with the x, so it is 8. The vertical radius is with the y, so it is 4. Many times students switch those because they look at it and think it's always the first and the second. That's not what it is. It's what is it kind of matched up with? What is it used with? This is the y part, so these will be the vertical component of your center, vertical component of your radius. These are horizontal. So we can draw in a rectangle using our key points. And from the center, we're going to go left and right 8. We're going to go up and down 4. And now 2, 3, and 2, -5, those are the actual vertices of hyperbola that is going to open up and down. So that would be the equation, and this would be the picture. A few things to pay close attention to in the example. The equations are identical except for the first hyperbola. The x part of the equation comes first, and the y part is the negative part. For the second hyperbola, the y part of the equation comes first, and the x part is negative. Both graphs have the same center, same horizontal radius, same vertical radius, same key points. Notice that in both equations, the x coordinate of the center and the horizontal radius are located with the x part of the equation. And then the y coordinate of the center and the y radius are located in the y part of the equation. So that's what I was talking about up here. We have to look and see what is it associated with. These are with the y. So that's the vertical part of the center and the vertical radius. So when the equation is in this form, x minus h squared over a squared minus y minus k squared over b squared, this is going to be one that opens left and right. The transverse axis is going to be horizontal. Center will be at HK. Horizontal radius is A. Vertical radius is B. So the vertex is going to be at HK, and I'm going to move A units left and A units right. So that's what this little statement here. So the vertices are going to be H minus A, comma K, H plus A, comma K. So that's how I can find those if those are the values I have. I would probably advise just drawing the picture, and then you'll find them. We change it, y minus k squared over b squared minus x minus h squared over a squared equals 1. Now it's going to open up and down. The x part's the part that's negative on this one. Transverse axis is then vertical. And now the vertices, the h will remain constant, and I will move up b, up that vertical radius, and down that vertical radius to find the two vertices. All right, so let's compare them with these two examples. So hyperbola number 1, center's at 3, 0. Horizontal radius is 2. Vertical radius is 7. Let's go left and right 2. Up and down 7. Be able to draw in the box, draw the diagonals. And this is one where the y squared is negative, so it opens left and right. So I'll use that vertex and that vertex, and then hug the asymptotes as we go. Y squared over 49 minus x minus 3 squared over 4 equals 1. Notice it's very similar to this one. Oh, that's different. Now the x part is negative. The y squared part is positive. So center is the same. Horizontal radius the same. Vertical radius the same. Because these are with the y and these are with the x. Key points still the same. Rectangle looks the same. Diagonals are the same. But now I'm going to use my 0.37 and 3, -7. And it's going to be a hyperbola that opens up and down. One additional thing to note, the length or height of the box does not determine whether the hyperbola opens left, right, or up or down. Sometimes students think, well, this is wider, so it must go this way. That is not the case. We only have to look at which of our values is positive and which is negative. So determine that by just looking at the equation. All right, so some more examples now when we're also going to be looking at some left and right and up and down. So center's at 0, 0. The y squared part is negative. x squared part is positive, so the positive part is where I'm going to find the transverse axis. So this is horizontal. I'm going to go left and right 2. I'm going to go up and down 3. Slopes of the asymptote. So again, I'm going up 3 and over 2. So my slope is going to be 3/2, up 3 over 2, and down 3 over 2, down 3 over 2. So those are the two slopes if we are talking about the slopes. It's centered at 0, 0, so I know it's actually going to be going through 0, 0 as well, so we could even write the equation for that one if we had to. So I draw in the rectangle, draw in the asymptotes, vertices, and then the sketch. This one's still centered at 0, 0. Now my horizontal radius is 1. My vertical radius is 4. So from 0, 0, I'm going to go left and right 1. From 0, 0, I'm going to go up and down 4. The slope on these are, I'm going to go up 4 over 1, and I'm going to go down 4 over 1. So I've got 4 over 1 and negative 4 over 1. And what we notice is it's always this b over a. So the square root of the number that's underneath the y over the square root of the number that's underneath the x squared. So that's our change in y over change in x, if you just think of it that way. That's our change in y, and that's our change in x. Opens up and down, so we sketch it that way. All right, next one. Now we give you the equation, have you pick out some different parts. So this one, we realize it's going to be horizontal. X squared is positive, y squared is negative, centered at 1, 2. Horizontal part of the rectangle is going to be 4. Vertical part of the rectangle from the center is going to be 8. So I'm going to go from 1, 2, left and right 4, up and down 8. So the actual vertices are going to be 4 left of 1, 2, and 4 right of 1, 2. So here's my list of the vertices, the actual points that are on the hyperbola. The slope, so it's my change in y, so vertical distance over the change in x, which is 4, so 8 over 4, which comes out to be a 2, and then it's also negative 2. Got one that goes down and one that goes up. And then rewriting in general form. So this is the first time that we get to this. So to rewrite in general form, remember general form, we want to have all of the variables on one side and the constants on the other, no parentheses or anything like that. So this is like dealing with the ellipse, except for I have a minus sign in there. So the first thing I'm going to try to find is what's a number that goes in, that 16 and 64 would both go into, and that would be 64. So as I look at that, I am going to multiply everything by 64. And then 16 goes into 64 4 times. Do some simplifying before we start multiplying. 64 goes into 64 1 time, and 1 times 64 is 64. So that's the first step that we have down here after we did the multiplying. So then we expand x minus 1 quantity squared, FOIL it out, FOIL that out, distribute the 4, 4x squared minus 8x plus 4, minus, distribute the negative. Be careful with that one. I've seen that one messed up before. Negative y squared plus 4y minus 4. So what happens on here is I move things to the constants to the right-hand side. We actually have a minus 4 and a plus 4, and those become 0. So it just stays as a 64. All right, so when I look at this general form, I can also tell that it's going to be a hyperbola because I've got positive 4x squared and minus y squared. So I can tell it's going to be a hyperbola, and I can even tell that it's going to open left and right because the x squared part is positive, the y squared part is negative. Let's look at the next one. All right, y minus 3 squared over 25 minus x plus 5 squared over 100 equals 1. Center, remember, for the x parts, we're looking at the x part of the equation. So we're at negative 5, positive 3. Oh, it is a vertical Transverse axis opening up and down because it's y squared minus the x squared part. Horizontal distance from the center is the square root of 100, so we're at 10. Square root of 25 is 5, so that's our vertical. The vertices, I'm going to go from the center, and since this one opens up and down, I'm going to go up 5 and down 5 from that 3. So I'm at negative 5, 8, and negative 5, negative 2. There they are. The asymptotes, change in y over change in x. So my change in y is 5, my change in x is 10. So 5 over 10, a little bit of work you can see over here. We end up with a half, and it's also negative a half for the other line, the diagonal going this way. Sketch in the diagonals and sketch in the hyperbolas. General form on this one, something that 25 and 100 both go into. So I think that number would be 100. So if I multiply by 100, multiply by 100, multiply by 100. So on that one, we get those to cross off to equal 1, and 25 goes into 104 times. So that's where we started down here. So then we're going to FOIL and FOIL that. So make sure that you distribute appropriately. Now we're going to distribute the 4, and we're going to distribute the negative. All right, so we've got that with no parentheses anymore. And then the last step would be, let's go ahead and take the constants and move them to the other side. So I'm going to add 25 and subtract 36 from 100, and that's where the 89 comes from. And you might see it written 4y squared minus x squared minus 24y minus 10x equals 89. Sometimes we'll put the higher degree terms kind of first over here. And again, that's going to tell us, because I've got a positive y squared and a negative x squared, I know it's going to be hyperbola. And this one I know is going to open up and down because the x squared is the part that's negative. I should be a little careful with that. That doesn't always have to be the case, because when we get to getting a 1 over on this side, this 1 over here, if I had to, in the solving steps, if I had to divide by negative, whatever number I had over here, that could actually change this. So you have to be a little careful, but I knew where it came from, so I knew that this was the positive and this one was the negative one. All right, next one, x plus 2 squared over 16 minus y squared over 25, centered at negative 2, 0. Horizontal radius is 4, vertical radius is 5. So change in y is 5, change in x is 4, so 5/4 and negative 5/4. The vertices, since this is a left and right opening one, I'm going to go 4 units left of negative 2, 0 to get negative 6, 0, and 4 units right of negative 2, 0 to get 2, 0. So we're there and we're there. I would draw in the rectangle. So from the center, I'm going to go up and down 5. And now I can draw in the rectangle and draw on the diagonals. I've got the slopes already. And then this one, 16 and 25, they don't have any factors in common. 25 is 5 times 5. 16 is 2 to the 4th, or 4 squared. Nothing in common. So on this one, what I would probably do, and I would even write it this way, I'm going to have to multiply by both of those. So I'm going to multiply by 16 times 25 on that, 16 times 25 on that, and 16 times 25 on the right-hand side as well. And I would write it like that, and I wouldn't write 400 because of what's going to happen next. What's going to happen next is I'm going to try to reduce. So what reduces is 16 over 16 becomes a 1. 25 over 25 becomes a 1. So I have 25 times x plus 2 squared. So that's what we're starting with down here. And 16 times y squared. And 1 times 16 times 25, that's where we get the 400. So that's where that part comes from. So we're getting good at expanding that binomial. And then we're going to distribute. And that one already is. And then we can move this to the other side. So we get a 300 over there. And we get a 25x squared plus 100x minus 16y squared equals 300. So again, variables on one side, no parentheses, and we combine all like terms, and we have constants on the other side. Last one, this one, y plus 3 quantity squared over 81 minus x minus 10 quantity squared over 49 equals 1. This is going to be vertical. This is the positive part. This is the negative part with the x. So positives with the y, so it's going to be vertical. Center is at 10, negative 3. Horizontal distance, so I go over to the x part, and it doesn't matter where that's located, the x part here. So the horizontal distance from center to the edge of the rectangle is 7, and the vertical part is going to be 9. Since this is opening up and down, I'm going to go from the center, I'm going to go up 9, and I'm going to go down 9. So I get those two vertices. The slope, change in y over change in x. So I'm going to go up 9 over 7 and down 9 over 7. So those are my two slopes. And then we can sketch the graph. Once we have the rectangle, we can put in the diagonals. I have my vertices already, and then we know it's opening up and opening down. And then the last piece here is go ahead and writing it in general form. This is similar to the last one where we don't have any common factors, 9 and 9 and 7 and 7. So I have to multiply by 81 times 49. And 81 times 49. And 81 times 49. And then 81s will simplify off there. 49s will simplify off there. So I get rid of the fractions. So now 49 times y plus 3 squared minus 81 times x minus 10 squared. And then 81 times 49 times 1 must be 3,969. Expand out the binomial. Distribute. Make sure you keep track of that negative sign there. So 49y squared plus 294y plus 441 minus 81x squared plus 1,620x minus 8,100. And then let's get the constants to the other side. So we're going to have to add 8,100, subtract 4,041, and that's how we end up with 11,628 on the right-hand side. And then we just have our variables on the left side. So that is the hyperbola. Notice it's very similar to the ellipse. The only difference really is I have a minus sign here instead of a plus. For the equation, that's the only difference. Obviously, when you look at the picture, there is quite a difference. But really, if you understand the ellipse, you should be able to make that rectangle. And once you make the rectangle and decide if it opens left or right or up or down, you should be able to get that. So there's the activity on hyperbolas. I think we should be ready to work through the worksheet now.